Hey guys, so today we're going to go over finding derivatives using the product, quotient, or higher order rules. So notice for the product and quotient rule, there is a function of x that we'll call f of x being multiplied or divided by another function of x that we'll call g of x. So I'm noting that because um, looking at the first example, which again, notice the instruction says you're finding dy over dx, which just means you're finding the derivative of y with respect to x because the function is in terms of x. Um, if I write this out just so you can kind of see it a little better, this is going to be two functions being divided by one another. However, notice that g of x, which would be the denominator, is not in terms of x. You could still apply the quotient rule. Just when we find the derivative of g, it will give you 0 because the derivative of any constant is 0. So what does that mean? You could use the quotient rule, but I wanted to take an algebraic approach to show you, just in case you have the freedom to pick and choose which rule you're applying, that if you see something like this, you can always just simplify the function before finding its derivative. So remember, you can always split a numerator. You cannot split a denominator, but you can always split a numerator, which means you can give each one in the numerator its own denominator of 5. So this is another way, x squared over 5 is another way to say 1 over 5 times x squared. And I can check that because the fraction form of x squared is x squared over 1, and if I multiply straight across, it will bring me right back up to x squared over 5. So you can always double check using your algebra, and if it's correct, it should bring you back up to the previous term. But what I have here now that I've split up the numerator is I have a sum of two terms, which means I can apply the power rule for each term in order to find the derivative of y with respect to x. So if I were to take 1 over 5 times x squared, I multiply the exponent times the coefficient. So I'm going to take a sidebar for that, 1 over 5 times 2. Remember, the fraction form of 2 is 2 over 1, and we multiply fractions straight across, so that will give me 2 over 5. And I take 1 away from the power, which would give me x to the first power, plus we have a constant on the next term, so that means the derivative of any constant will just be 0, and we don't need to write plus the 0, so this would be our derivative. So notice I didn't use the quotient rule, I applied an algebraic approach and then found the derivative. So it is possible, just like we did for number 2 in the previous example, I actually FOILed it or distribute it and then found the derivative using the power rule again, or the product and sum rule, which was the power rule for each term. In this case, however, I am going to actually use the product rule and not take the algebra approach. So notice I have two functions of x being multiplied to each other. So for number 2, before I even apply the product rule, I'm just going to kind of do my housekeeping, meaning note down what the first function is, which is 3x minus 2x squared. And I'm going to note the second function, which I'm going to need a little more room, so let me just write it a little closer there. So f of x equals 3x minus 2x squared. The other function of x that it's being multiplied by is g of x, which is 5 plus 4x. Sorry, cut off when I wrote x. Okay, so if you note, I need to know what f prime of x is and g prime of x is, meaning the derivative of each one of them. So f prime, we're going to just use the power rule for each term. So 3 times 1 would give me 3, and 1 minus 1 is 0, so it would just be 3, minus 2 times 2 is 4, and if I take 1 away from the power, I'll get x to the first power. So for g prime of x, I'm just not writing the x just so I have a little bit more room. I'm taking the derivative of 5, which is a constant, so that would be 0. I'm not going to write that down, but you could write 0 if it makes you feel better. And then the power of x for the second term is 1. 1 times 4 is 4. And if I take 1 away from the power of 1, it will give me x to the 0 power, which is just 1. And then 4 times 1 is 4. So g prime equals 4. Okay, so we have this all set up, which means now to find the derivative of y with respect to x, I'm going to write down my product rule, which is f prime g plus f g prime. So all I'm doing is I'm going to substitute what I have into each variable's place. So f prime is 3 minus 4x. Remember, you always substitute in parentheses. Times g, which is 5 plus 4x. And then it's being added to f, which is 3x minus 2x squared times g prime, which is just 4. So in this case, we are going to make sure we apply PEMDAS properly, meaning we're going to multiply before we start adding and subtracting. If you look at the first two, they're being multiplied, you are going to FOIL, or you could distribute, but two binomials you could FOIL, so first times first would give me 15. 3 times 4x would be plus 12x. So I'll just label that if you need. First, outer, inner. Negative 4 times 5 would give me negative 20x. And then last, negative 4x times positive 4x is negative 16. And remember, when you multiply, you add the exponents. Each one has an exponent of 1, so that's 16x squared. Okay, now the nice thing about after the plus sign is I'm distributing a 4 just to each one of these terms in the parentheses. I could put the 4 in the beginning if that, kind of makes you feel better. Remember, when you multiply, it doesn't matter the order. 3 times 2, 2 times 3, it's all going to be 6. So if I put the 4 in the beginning to distribute and multiply it, it's the same thing as if it's on the end and I distribute and multiply it. So it's only going to be distributed and multiplied here because there's a plus sign, so we're not multiplying over there. So this would give me plus 12x minus 8x squared. Okay, nothing but plus and minus now, so using PEMDAS, we're just going to add and subtract our like terms. So from highest exponent to smallest exponent, let's go with x squared. We have negative 16x squared minus 8x squared, and that would give me negative 24x squared. Then from here we have negative 20x plus 12x and plus 12x. All right, so we have negative 20 plus 12, and that will give me positive 4x. And then from here, I have plus 15. So I don't have anything else. It's a positive 15, so I'm just going to bring that down. And this would be my derivative. All right, guys, hope this helped.